Steel, one of the most fundamental and essential materials in modern life, has played a key role in the advancement of human civilization for thousands of years. Since the Bronze Age, when humans began using metals to create tools and weapons, steel has gradually become an indispensable part of every field. Tools and weapons made from iron and steel have transformed the ways of warfare and production, helping ancient civilizations such as Egypt, Rome, and Greece to thrive. The steel industry has undergone many developmental phases, from the early use of raw iron to the present day, where steel production technology has become more sophisticated and modern than ever. The development of the steel industry has led to the construction of magnificent structures like the Eiffel Tower, the Golden Gate Bridge, and many other skyscrapers, proving that steel is not just a material, but also a symbol of strength, resilience, and human creativity. Today, steel is widely used in construction, machinery manufacturing, automotive production, and even in electronics. With millions of tons of steel produced each year, the steel industry has created millions of jobs and is a crucial part of the global economy. Steel is not just a material, it is also a key factor in building infrastructure and economic development in nations. From large constructions to small products, steel is present everywhere in our daily lives. The continuous development of steel production technology has opened new avenues for this industry. Scientists and engineers are constantly researching to find more efficient, energy-saving, and environmentally friendly methods of steel production. This not only enhances the quality of steel, but also minimizes the environmental impact of the steel industry, a growing concern in the context of current climate change. The steel industry also faces many challenges, including global competition, fluctuating raw material prices, and the increasing demand for high-quality steel products. However, with technological advancements and innovations in production processes, the steel industry still has the potential to overcome these challenges and continue to grow in the future. Let's explore deeper into the steel production process, from iron ore to the final product, where creativity, technology, and future vision converge to create sustainable and high-quality products for humanity. Every drop of steel we use in our daily lives starts from iron ore, a valuable raw material mined from the earth. Iron ore is typically found in rocky mountainous areas and contains a high amount of iron oxides, forming large rocks that range in color from reddish-brown to dark gray. The richest iron ore deposits are found in Australia, Brazil, and China, where large mines provide millions of tons of ore each year for the global steel industry. The process of mining iron ore is not merely about digging. It also involves many complex refining steps. First, iron ore is harvested from mines using modern machinery. Once collected, the ore is crushed into fine powder to increase the surface area for the removal of impurities in subsequent steps. This way, the efficiency of the steel production process is optimized, ensuring that the input materials meet the highest quality standards. After being crushed, methods like magnetic separation and flotation are used to extract iron from unwanted minerals. This step is crucial because it directly affects the efficiency and quality of the final steel. Removing impurities not only increases the iron content in the ore, but also enhances the strength and corrosion resistance of the steel in later applications. In addition to iron ore, coke is an indispensable raw material in the steel production process. Coke, produced from coal through a heating process in the absence of air, not only provides the necessary temperatures to melt iron, but also participates in important chemical reactions within the steel furnace. The production of coke requires high technique and modern technology to ensure that it meets optimal quality. Limestone, another common mineral, is also an essential component in the steelmaking process. Limestone helps remove impurities and acts as a flux, combining with impurities to form slag, which aids in separating them from the molten iron. This process is vital because it not only cleans the steel, but also enhances the strength of the final product. Thus, the three main components, iron ore, coke, and limestone, form a solid foundation for the steel production process, leading us on an exciting journey from the earth to high-quality steel products. The preparation of raw materials does not stop at mining and processing the ore. Attention must also be paid to safety and environmental standards. Iron ore mining can have significant environmental impacts, from land degradation to water pollution. Steel manufacturing companies today are implementing measures to protect the environment during the mining and processing of ore, including the use of clean technology and effective waste management. This ensures that the steel industry develops sustainably and is environmentally friendly. Once the iron ore, coke, and limestone are prepared, they are fed into one of the most crucial parts of the steel production process, the blast furnace. The blast furnace is a colossal structure, typically over 30 meters tall, where limestone combines with impurities to form slag, aiding in their separation from the molten iron. This process takes place under extreme conditions and requires modern technology to control factors such as temperature and pressure. Sensors and automated systems are installed to monitor and adjust parameters within the furnace, ensuring that chemical reactions occur in the most optimal and efficient manner. Once molten iron is carried out in steelmaking furnaces, the two primary methods used are the basic oxygen furnace, BOF, and the electric arc furnace, EAF. The basic oxygen furnace is the traditional method, where oxygen is blown into pig iron to lower the carbon content, producing steel. Meanwhile, the electric arc furnace uses electricity to melt and refine steel from scrap. Each method has its own advantages and disadvantages, but both aim to produce high-strength steel technology combined to create sustainable products for the future. After molten iron has been produced, the next stage in the steel production process is casting and processing. This is one of the most crucial steps that determine the shape, size, and properties of the final steel products. There are two main methods used in the casting process: continuous casting and mold casting. Each method has its own advantages and disadvantages, but both aim to produce high. This stage not only helps improve mechanical properties, but also enhances the strength of the product. Heat treatment is the process of heating steel to a certain temperature and then rapidly cooling it to create desired microstructures, thereby improving strength and mechanical properties. After going through the processing stages, the steel products are subjected to quality checks to ensure that they meet strict standards for strength, hardness, and stability. This quality inspection includes methods such as tensile strength testing, hardness testing, and microstructure analysis using electron microscopy. Steel products must pass these tests before being released to the market, ensuring that customers receive the highest quality products. The casting and processing stage of steel is not just a production process, but also an art, where creativity and technique meet to create products that meet the demands of modern life. Steel is not just a material, it is a reflection of human creativity and innovation. By mastering the processes of casting and processing, the steel industry continues to evolve, providing essential products for infrastructure and modern technology. In the steel industry, quality control plays a crucial role in ensuring that every product meets the strict standards set by manufacturers and customers. Quality control is a systematic process that involves regular inspections and tests throughout the steel production process, from raw material preparation to final product delivery. This ensures that the final steel products possess the necessary properties for different applications. One of the key aspects of quality control in steel production is monitoring raw materials. Infrastructure projects must for steel manufacturers worldwide. One of the primary concerns in steel production is the carbon footprint associated with traditional methods, particularly the use of coal in blast furnaces. The combustion of fossil fuels releases large amounts of carbon dioxide, CO2, contributing to climate change. To address this issue, the steel industry is actively researching and implementing cleaner technologies, such as direct reduced iron (DRI) processes that use natural gas instead of coal, significantly reducing CO2 emissions. Another key aspect of sustainability in the steel industry is the efficient use of resources. The recycling of steel is one of the most effective ways to reduce environmental impacts. Steel is one of the most recycled materials globally, with about 70% of the steel produced coming from recycled sources. This not only conserves natural resources but also reduces energy consumption and waste associated with mining and processing raw materials. Steel manufacturers are also exploring the use of alternative materials and production methods. Innovations such as electric arc furnaces, EAF, use electricity to melt scrap steel, drastically lowering emissions compared to traditional blast furnace methods. This shift toward electric furnaces is becoming more popular as renewable energy sources, such as wind and solar power, become more widely available. In addition to technological advancements, the steel industry is increasingly focusing on sustainable practices in its supply chains. This includes ensuring that raw materials are sourced responsibly, minimizing waste generation, and implementing recycling initiatives. By prioritizing sustainability at every stage of the production process, steel manufacturers can contribute to a more circular economy. Environmental regulations and standards are also driving growth in steel production. One of the primary challenges facing the steel industry is the need to reduce carbon emissions in response to climate change. Governments and organizations worldwide are setting ambitious targets for carbon neutrality, pushing the steel industry to adopt cleaner production methods. This shift requires substantial investment in research and development to create new technologies that can minimize emissions while maintaining steel quality and performance. Technological advancements are playing a pivotal role in transforming the steel production process. Automation, artificial intelligence, AI, and machine learning are increasingly being integrated into steel manufacturing operations. These technologies enhance production efficiency, improve quality control, and enable real-time monitoring of processes. As manufacturers adopt digital solutions, they can respond more effectively to market demands and optimize their production processes. The demand for specialized steel products is also growing, driven by advancements in various industries, such as automotive, construction, and renewable energy. As consumers seek higher quality and more durable materials, steel manufacturers are focusing on developing innovative products that meet specific requirements. This includes high-strength steels, corrosion-resistant steels, and lightweight alloys, all of which contribute to the performance and sustainability of end products. Global competition is another significant challenge for the steel industry. As emerging economies continue to develop their steel industries, established players must adapt to remain competitive. This requires not only improving efficiency and reducing costs, but also enhancing product quality and service offerings. Collaboration and partnerships across the supply chain can help steel manufacturers gain a competitive edge in a dynamic global market. In addition to these challenges, the steel industry has the opportunity to play a critical role in supporting sustainable development. Steel is essential for infrastructure projects, renewable energy systems, and advanced manufacturing. By focusing on sustainable practices and producing high-quality steel products, the industry can contribute to the global transition to a low-carbon economy. Furthermore, as consumers become more environmentally conscious, they are increasingly seeking products made from sustainable materials. Steel manufacturers that prioritize sustainability and transparency in their operations can differentiate themselves in the market and attract environmentally conscious consumers. In conclusion, the future of steel production is characterized by both challenges and opportunities. By embracing innovation, adopting sustainable practices, and responding to changing market demands, the steel industry can continue to thrive and contribute to a more sustainable and resilient global economy.